Good morning to all. Today we are going to discuss the topic interrupts. So, in general term, what an interrupt is called as? Interrupt is called as any kind of the unnecessary event or unnecessary kind of the task that breaks our normal execution or any kind of the task we are doing, and later on we have to resume with the same kind of the task. Simply that is called as an interrupt. Now, in terms of the computer technology, in terms of the computer hardware, or in terms of the operating system or computer architecture, exactly or technically, what is an interrupt? Interrupt is a kind of the signal, a kind of an event that is generated by a number of the processes, number of the hardware devices, like all the memory buses, system buses, data buses, or we can say control buses also. Or we say know that operating system keeps on executing the number of the processes at the same time to implementing the concept of the multi-programming. So how those processes are keep on executing one after the another, or how one process came to know, or how that process is intimated by the processor that yes, one process has been executed completely, or is there any kind of the issue with that process. Everything is implemented with help of an interrupt. We know of that computer or any machine that understand which language or only 0 and 1. So how one user is able to interact with the computer system, how any kind of the instruction, any kind of the command or any kind of the program that can be make interactable with the computer system, or how we get the response back from the computer system after executing any kind of the task. That is possible with help of an interrupt. So, very common example in our daily life. Let's say when you are studying and your cell phone rings, then what you will do? Definitely you will do one task at a time. You can't study and you can't attend your phone call at the same time. That's not possible. So simply what you can do, let's say you will finish the talking on the phone and then you will be continued with your study. Very first aspect is that. Second, let's say now your phone rings again and someone also knocking at the door. Then what you will do? Now what is the aspect that now there are the two kind of the interruptions at the same time. Either you have to attend a phone call or you have to look at the door that who is knocking at the door. So now what you will do, or which kind of the task you will prefer to choose at the same time. So that is also kind of the interrupt. Or at the same time what we can say that there are the number of the interrupts and we have to choose that which interrupt we have to handle or which kind of the task, or simply technically we say we have to prioritize the interrupts at the same time. Look, let's say interrupt has the priority. Some interrupts are more important over the others. For example, asking your phone is more important than opening the door. Obviously, that is a very practical example. So let's see some more example and this is in the detail technically about the interrupt in our computer system. So interrupt is used to cause temporary halt in the execution of any program. So most important is which kind of the pause or halt will be, that is the temporary one. That's not permanently. Fine. So interrupt is event that breaks the sequence of the operations in the processor so that processor can attend the task needing the completion because of an event. So normally what's happened? Let's say now I'm delivering the lecture and in between the lecture somebody is calling me outside or knocking at the door. So let's say I will stop in between and look at the door, or will see that what kind of the task, and later on I will resume where I have left off. So that is also called as an interrupt. And most important is that when an interrupt occurs within the computer system, second one, what to do when there is an interrupt. Third one, how to handle that interrupt, and last, that what to do after interrupt has been handled. That's all the issues, or we can say a one complete cycle is there that we have to follow whenever there is any kind of the interrupt. So interrupt process where an external device can get the attention of the microprocessor, or technically let's say one computer system having one processor is there, one operating system is there, but at the same time, what is the possibility that number of the, or we can say multiple users will be there, multiple tasks will be there, or multiple kind of the processes that users have to execute at the same time with help of the single operating system and single processor. So how does all the multiple tasks will be managed by the one processor and will be executed one after the another in some kind of the, we can say, sequence. So interrupt is that kind of the mechanism that needs, or that will intimate to the processor or your computer system that I need attention, I have to do some kind of the task, please provide me the services, or simply it kind of the signal. Fine, I have told you earlier also that computer can understand only 0 and 1. So our request that yes, I need to access the memory, I need to read or write some kind of the data in the main memory, I need to store something, I need to, let's say, use the any kind of the web browser. Fine, first of all, what I have to do? I have to gain, or I will make the request to the processor that I have to execute this particular task. How I will do that? I will interrupt the processor that please give me some time, or please execute my task. Fine. So that request will be raised with help of an interrupt, or you can say with the help of the signal, because interrupt is what? Simply a kind of the signal in form of the 0 and 1. So now there are the two possibilities that processor can immediately pay the attention that why we are generating an interrupt. Fine, and it will keep on executing our task. Second, processor is quite busy, it have lot of the tasks to do. So processor may ignore our request, or what we can say, processor can put our request on hold, or we have to wait that when one processor will attend our interrupt. Fine. So that's called as the interrupt service routine. I'm repeating the term interrupt service routine, that what processor will do when we will generate an interrupt. Fine. Or we will intimate to the processor that please execute these particular number of these steps. Then what will happen? Processor will breaks or stop the current running process in between. It will look for that what kind of the task user want to execute, or why there is an interrupt. It will handle the interrupt. Fine. That handling the interrupt is called as the interrupt service routine. And once interrupt service routine has been handled successfully by one processor, then it will resume with the normal execution and user will obtain or get any kind of the output. So let's move next. Fine. As I told you, what happens when an interrupt occurs? Simply, let's revise. Processor will break its routine very first. Then go to the different routine. Which kind of the routine I have told you earlier also? Interrupt service routine. That why there is an interrupt in the computer system. And complete the interrupt service routine. Fine. And then go back to the normal routine. It looks quite easy, but most important is that how processor will pause with its current execution, and later on how it will came to know that from where that particular execution has to be resumed. That's very, very important. So let's see. Fine. Or PC, very important term, program counter. So what is the program counter? If you don't know, let me tell you very simply. program counter is what? That keeps the address of next instruction to be executed. Because very simple definition of any kind of the program or any kind of the software is what? A sequence of the number of the steps or number of the commands. So same here, let's say processor, or let's say simply we are executing one simple C++ program. Let's say we are also we are downloading one any kind of the movies here, or we are on a call, let's say. So fine, how that at the back end that is implemented? By executing the sequence of the steps one after the another. So now what program counter will do? Let's say number of these steps in our this particular example, that is 100, 101, 2, 3 and 4. Or let's suppose where is the current execution, or which current at a particular time processor is executing which number of the instruction? 102. So program counter will keep the address of which instruction next to be executed, or simply 103. So now here is an interrupt. Fine. So we have to stop where? Right at 1, 0 and 2. So we need to say that now 102 has been executed, and which is the next instruction to be executed, that is the 103. So that will keep the address of 103. And look here, we are also using the stack that will store the address that later on when we have handled the ISR or processor have executed or handled the interrupt successfully. So we have to resume later on. How we will do that? We will look at the stack, that which is the address provided by the program counter. Simply, let's say 103. So later on, we will look at the stack only, or for address of the program counter, and we will decide accordingly that from where we have to resume exactly in our example also 1, 0 and 3. So that's the number of the steps, that what happens or how one processor will handle one interrupt in our computer system. And most importantly, I'm repeating again, that the particular execution that will not be stopped permanently, that will be for temporary period of the time, or we can say the time taken by the processor to handle the interrupt. Meanwhile, we will wait that when our processor will complete or handle the interrupt. So fine. So again, let's summarize the or what we have elaborated. Should be able to accept the interrupt. First of all, fine. Save the last content of the program counter, as we have elaborated in the example also. Know where to go in the program memory to execute that ISR. Fine. Tell the outside world that it is executing the interrupt, and also when processor is handling one interrupt, fine, it needs to make aware all the other users, processes, programs, and all the, you can say, hardware or software components or parts of the computer system, that right now I'm engaging or I'm already executing or handling one ISR. So please do not interrupt me. Please wait for some time, and later on when I will finish with the one ISR, you can initiate the next one. Fine. Let's say I'm taking the lecture right now. So obviously if somebody else have to take the lecture in the same lecture hall, then has to wait outside, because right now I am already taking the lecture in this particular lecture hall. Fine. So response to the interrupt. Now in the previous slide we have seen that processor needs to handle the interrupt, or how it will intimate the other components that it's already executing the ISR. Fine. So depends on that ISR, we can categorize the interrupt into major categories. One is the vectored interrupt, and second is the non-vectored interrupts. And generally vectored means mathematics term, very common mathematics term is direction, one particular direction. Fine. So the address of the subroutine is already known to the microprocessor, or where to execute the ISR or where to store or handle the ISR within the main memory, if that particular address is already known to the microprocessor during handling the interrupt, that we can say that is the vector. And when that particular address is not known or processor has, first of all, to look for that particular address only, that will be called as the non-vectored interrupt. Fine. So I think so. Now you must have got an idea what is an interrupt. Fine. Why to create an interrupt, and what processor will do whenever any user or process will create an interrupt. Fine. Or let us take one more or very practical example is there. Let's say we are on a call. I'm already, let's say, on a call, and between someone else making me call, then what will happen? Whether I will be intimated that at the same time somebody is also making me call or not? Obviously, yes, I will be intimated, and next person will also be intimated that the person you are calling is on the another call. Please wait again, or wait after some time, or please wait. Fine. So how is that possible? That means at the back end, all the time, your processor is making the calculation that which process is in the execution or which currently task that is the more important, and if there is a kind of the interrupt, whether to handle that interrupt immediately or let's say to ignore that interrupt for temporary amount of the time. That same we are going to discuss next also. Fine. Need of interrupt, we have already discussed that if we have to interact with the computer system, we have to use the any kind of the application program. Let's say in the smartphone also we have to open the Google Chrome. Well, we click on the double click, or let's say we have to open any kind of the data, or let's say my favorite movie in my hard disk. Obviously I will double click on that particular folder. So what is the meaning of that double click, or what happens when we double click on a folder? Fine. So what we are doing now, we are requesting to the processor, or we are requesting to the kernel that yes, please, I want to play some kind of the song or a movie, please let me open for me. Fine. So at that time one request will be generated on the behalf of the user of the computer system that please provide the access to the particular user at this particular folder in the main memory. So how that request will be handled by the operating system or the processor? Fine, that is called as the interrupt handling also, or we can say need for an interrupt. Fine. Interrupt increases the processor system efficiency by letting all the input output. Input output simply means, let's say, any kind of the output devices, let's say printer, scanner, microphone, headphone, fine, projector also, any kind of the external hard disk also, CDs, DVDs, fine. Request the CPU time only when that device needs immediate attention, fine. Or simply, let's say, when somebody will make me a request only when some kind of the immediate attention needed by that particular person. So same happens with the computer system also. So same here, let's say we have to type something on the keyboard. Fine, so how that's possible? Whenever we press a word, so keystroke will generate one interrupt to the input output handler, or that device driver of one particular device, that yes, user is continuously typing something, and according to that please provide the output to the user also. That means interrupts are generated as per the request of the user. If my typing speed is slow, fine, I'm not able to type so fast, the number of the interrupts generated, that will be it will be few. Fine. If my typing speed is quite fast, the number of the interrupts generated, that will be more. And now how we can categorize the interrupt? Fine. Very first category, that is the hardware interrupt and software interrupt. Fine. So first of all, let's talk about the hardware interrupt. Fine. What are the hardware or term? Hardware and software, very general terms. Fine. Hardware simply we say that the any kind of the hardware components or any kind of the devices that we can attach or detach with the computer system. So now hardware interrupts are those kind of the interrupts which are related to the all the registered hardware components of your computer system. Fine, I am saying registered components, hardware components. For example, charging slot of your smartphone. Fine, a microphone jack of your smartphone. Similarly, USB ports within the one computer system, charging slot within the computer system. So what we say, these kind or also let's say any kind of the CD or DVD player is there, RAM or you can say memory slots are there, external buses slots are there. So those are called as the registered devices. Whose registered devices means that are already known by the processor. Fine, processor allocates one unique device ID to all these kind of the devices, and whenever there is an interrupt generated by from those registered devices, fine, so processor is not or nothing to worry that who is creating the interrupt. One particular device ID allocated by the processor to multiple hardware components or hardware devices that is already known to the processor, and it can distinguish between all the devices quite easily that who is actually generating the interrupts. Parallelly, software interrupts are what any kind of the interrupts that are generated by the any kind of the user applications. Fine, application software or any kind of the utility tools, basically called as the software interrupts. And one more categorization is there. Let's say you will see here also, one is the maskable interrupts and another is the non-maskable interrupts. So as I told you earlier, that let's say processor can attend to the interrupt immediately, or it will also put one interrupt in the waiting that please wait for some time, I will handle you later on. So same here, I am saying maskable interrupts and non-maskable interrupts. Now maskable interrupts are what? Fine, that can be ignored by the processor for some period of the time, or what we can say that yes, processor can delay the handling of that particular interrupt, that is the maskable interrupt. And contrast, non-maskable means kind of the interrupts. Fine, if there is, processor cannot simply ignore that kind of the interrupt, it must have to execute ISR. What was the ISR? Interrupt service routine for that interrupt. That are kind of the non-maskable interrupts, or simply kind of the interrupts we can't ignore at all, or very crucial or very important from any kind of the execution point of view, or let's say from the processor point of view, or very important kind of the application executed by user at that particular time. So that are the maskable and non-maskable interrupt. Fine. Look again, hardware and software interrupt. Interrupt causes the processor to save its states of the execution and to begin the execution of the interrupt handler. In case of the software interrupt, usually implemented as the instructions in the instruction sets. Let's suppose Google Chrome is there. Fine. Already we know that with Google Chrome, there are the number of the settings. Fine. Let's say anytime we can look for the download folder also. We can look for the privacy settings also. We can look for the number of the tabs. Fine. And what kind of the contents we want to access on the Google Chrome. We can look for this kind of the settings anytime. Fine. And look, whenever Google Chrome finished with one kind of the downloading, let's say we are downloading the multiple songs at the same times, and once one song has been downloaded completely, immediately we got one notification is there that yes, this song has been downloaded, fine. So what does mean? That means it is predefined, or predefined instruction is there that is related to the Google Chrome, that yes, you will provide the notification or interrupt to the user that yes, your download has been finished. Let's see whether you want to open it right now or you want to open it later on. So that kind of the instructions are called as the software instructions. So non-maskable interrupt, that program cannot control when a non-maskable interrupt is succeeds. User is not the operator in case of the non-maskable interrupt. Fine. The processor has to stop the main program to execute the non-maskable interrupt service routine. Fine. And maskable, the programmer can choose to mask the specific interrupts and re-enable them later on. Very practical example in case of the non-maskable interrupts. Let's say we got the notification on the from the Google Play Store that yes, this number of the apps needs to be updated, and whether immediately we open the Google Play Store and keeps on updating all those apps, not all the time. Simply we click on the remind me later, or let's say some kind of the system or software updates are there, whether in case of the smartphones or desktop and laptop systems. What we do? We will simply click on remind me later, or please restart later on. So what we are doing at that time? We are simply ignoring, or we are re-enabling the interrupts for next time. Right? That means we are putting those kind of the interrupts in the waiting states. We are not going to halt our current execution in between, as already we are doing very important task at that time. Why? Non-maskable interrupts used during the power failure, let's say only 1% battery remaining is there. So what your system will do? Now it will not wait that all the time user will, let's say, click on the remind me later. No, then you have to do something immediately if you want to use your system. Fine, or already you are executing something very important, and in between there is, let's say, power failure is there. Now you do not want to lose your task, so you have to do something. You have to take some break in between and need to connect the charger very immediately. Fine, and used during the critical response times. Fine, let's say in terms of the embedded systems. Fine, for example, in aircraft control systems, in anti-missile systems. Fine, that are the based upon the rigid time instructions. Fine, in those kind of the embedded systems, we can't ignore what kind of the notification or what kind of the alerts are there. So we have to respond, and we have to plan our steps accordingly in case of the non-maskable interrupts. Used during the non-recoverably hardware errors. Fine, use as the watchdog interrupts and used during the memory parity errors. Let's say there is any kind of the system fault, or let's say you are not able to store or access your data in the main memory, or due to any failure, let's say any reason, technically or not technically, fine, any kind of the fault in your main memory. So system will immediately provide you one attention that yes, you need to look for that there is any kind of the error with your main memory. So these kind of the interrupt are non-maskable interrupt, or simply I'm repeating again, non-maskable means interrupts that we can't keep on ignoring all the time. We have to do, or we have to initiate some kind of immediate action in case of the non-maskable interrupt. Fine, software interrupts used by the operating system to provide who can do the various functions. Fine, and use of the communication mechanism between the different parts of the program. I have told you earlier also that software interrupts particularly related with any kind of the system, program, system tool, or any particular process that is to be executed by the user only. Fine. So let's move next also. Look, hardware interrupts, all the peripheral, keyboard, fine, or major devices, all the input, output, or hardware components, fine, have already device IDs or that are already known to your computer systems. Fine. 5 hardware interrupts are fine. First of all, let's say trap, RST 7.5, fine, 6.5, 5.5, and INTR, fine. So among these hardware interrupts, or let's say we were talking about, let's say if you're doing something very important, and in between you got the notification that now, let's say battery remaining only, let's say 1% is there. So we need to connect the charger immediately without wasting any time. Fine. So how we will implement it at that time? With non-maskable interrupt, or one kind of the interrupt having the or you can say very maximum priority among the other interrupts. So based upon various interrupts also, fine, maskable or non-maskable or vectored or not, fine, already very common locally type of the interrupts that are known to the processor and that are already categorized within our computer system without letting know to the users that yes, we have categorized the interrupt. Fine, let's suppose we have to plan our task within, let's say that yes, I will do this task at very first, second, third, and so on. I'm not going to share with somebody else. Fine. Similarly, one processor, one computing system, kernel of the operating system, fine, have the predefined sequence or predefined the priorities among all the interrupts, and that is not aware to the any kind of the user that how one computer system is going on or is going to handle the interrupts. Fine. Or let's say which kind of the interrupt is maximum priority? Trap. Fine. Or where we use the trap actually, let us discuss the one example also. During the multi-programming, fine, or let's say there is a kind of the situation, or let's say starvation is there in case of the computer system, that processor need to stop the current execution from, fine, and let's bring in that process that is waiting since long time, or we can say that continuously that was in the waiting state, or any alarming station is there, that we also call it the starvation in case of the operating system or process scheduling. Fine. So at that time, how of the trap? Fine. Trap will make alert to all the processes, to process scheduler or within the kernel system, that now starvation is there. We need to stop current execution in between, save the execution, fine, to resume it later on as we discussed in the case of the interrupt also, fine, and let me execute that particular process who is in the waiting state for very long time to break the chain for the starvation. There, this kind of the interrupt is used by the computing system to make the communication among all the devices, all the processes, and we can say that let's say we wish good morning to our friends. Fine. So same here, how processor will intimate or communicate with all the devices or manage all the things with help of the interrupt. Fine. So I hope so that we have discussed all about the interrupt, need of an interrupt. Fine. Or you can say type of the interrupt service routine, or what happens when there is an interrupt occurs within the computer system. Fine, like program counter was there, stack was there, or what kind of the interrupts, types of the interrupt are there, hardware interrupt, software interrupt, then maskable and non-maskable interrupt also. Fine. So thanks for watching the video. Fine. So let's discuss the next topic, deadlock, in our next topic.